My name is Ian, and I'm a research scientist with the Lower Columbia Estuary Partnership. Today, we'll be discussing visualizing and analyzing 10 years of wetland monitoring habitat data using Tableau. So what are we actually going to be talking about today? First, we'll discuss the data that we have and the two monitoring programs that go into that data. Next, we'll discuss some of the background behind Tableau and an overview of Tableau as a data management platform. We'll follow that up with how we at the Estuary Partnership are transitioning our datasets into Tableau, as well as some examples of how we've done that. And we'll conclude with some next steps of where we will be going from here. So the two monitoring programs that we have are the Ecosystem Monitoring Program and the Action Effectiveness Monitoring and Research Program. These two programs are related, yet distinct. The EMP program is a long-term status and trends monitoring of ecosystem conditions. It provides a basic understanding and fills knowledge gaps on the Lower River. It provides a suite of reference sites for the Action Effectiveness Monitoring program as well. The AMR program allows for evaluation of whether a restoration action achieved the goal of the project. It provides a quantitative understanding of the benefit of that restoration action, and it depends upon the EMP for results. The Ecosystem Monitoring Program is designed to understand habitat conditions. It has a suite of data that is not possible without the help of many other researchers. We collect mainstem and abiotic site conditions, habitat structure, food web dynamics, fish prey and macroinvertebrate communities, fish occurrence, and some other odds and ends here and there. Thank you to everybody who has helped us collect data for that. The AMR program has more limited data, yet at a great many more sites. With the AMR program, we collect habitat data, macroinvertebrate community, and fish community, and that's about it. We do collect some other odds and ends here and there, but it's not as in-depth as the EMP program. So with all of this data, we really just need a proper data management system. So we have over 70 sites with gigabytes to terabytes of data. It's just too much for many programs out there. We have 7 million hydrology data points alone. We also have food web stuff, animal stuff, other stuff, drone stuff. We just have a lot of long, complicated time series data. So we need special software basically to really go through it. So what are some software options we can use for this, and what do we have to consider about it? We have looked at Excel, SQL-based databases, R, Python, Tableau, some other odds and ends here and there as well. So the first big thing we need to consider are data limits. Excel, for example, has a hard data limit of 1,048,000 cells. You cannot have more than that. Next is the database capacity. What kind of data can it store? For example, the ARC suite is not great with long time series data, but it does mapping beautifully. How easy is it to teach somebody the software? It's pretty easy to teach somebody basic Excel, however, teaching somebody R is a lot more involved. How easy is it to edit, analyze, and graph your data? Something like Excel, you click the scatter plot button and it's graphed. Something like R, you have to play with ggplot and it's a pain. How easy is it to make maps and geolocate your data? Excel does not map stuff. It just doesn't. SQL, again, doesn't. ArcPro, it does. How easy is it to share this data with other people? Are there proprietary data formats, software requirements, etc.? Can I just send somebody a PDF of the thing and can they access it and use the data or not? How easy is it to share and present this data, and can we host this data online? For example, we can host like ArcMaps online and we can like send somebody a link and they can open it up and explore it themselves. Lastly, how expensive is that software? Does everybody who wants to collaborate need that software as well? Or is it only like the analyst who needs the software? So Tableau answers all of this. So I've been saying Tableau a lot, so what exactly is Tableau? Tableau is what the cool kids are doing, but it's also a data visualization software with advanced analysis capabilities. It is primarily used by the finance sector, but it's being rapidly adopted by various scientific communities, from everything from geology to computer science to physics, chemistry, astronomy, music. There's just so many communities that are adopting Tableau. It really emphasizes seeing and understanding the data insights for both the analyst and the audience. So as you are exploring the data yourself, you can really understand some conclusions. And as the audience, we can explore other people's data sets and understand and draw insight. Tableau is kind of the next step in the world of visualization. It really emphasizes that exploring of the data, and it complements reports pretty phenomenally. So the next few slides are going to be talking about our most noble cause of transitioning into Tableau. So the general data structure behind Tableau is called a relational table database. Tableau does something a little bit different with that, where you can use a mixture of file types and kind of map them together almost like a spider web on a single common class, if you will. So we have a mixture of CSV files, Excel files, and shape files. We also have some other file types, but that's unimportant. Those three file types are pretty commonly used for all of us, I think, and you can easily map them together based on the project name or the date or elevations or whatever. You can publish this data so multiple people can draw from the same tables as well. You don't have to necessarily publish it to Tableau Online's server. You can publish it to any other industry server that you want to, from Redshift to the Esri servers to Snowflake, whatever. It will work. Tableau Online is just Tableau's proprietary data system, and it makes it really easy to just connect to and use it on Tableau Online. But if you think your data is too grumpy for Tableau right off the bat, you can run it through Tableau Prep to improve it. Tableau Prep cannot quite change the laws of physics, but it does offer significant performance increases. Basically, it creates a hyperfile, which is Tableau's database system, but you don't have to do any of the SQL behind it to create that database. You just kind of drag and drop and select the function that you want to use, and it will do that function based on whatever parameters you set. You can clean stuff, union stuff, join stuff, pivot stuff, unpivot stuff, aggregate stuff, do script predictions, and export to several different formats. You can export it to everything from Snowflake to Tableau Online to just a straight CSV file if you want to. It's very user-friendly, and yeah, it's pretty nice to use. So what are some basic things you can do in Tableau? Tableau is really good at combining georeferencing and visualization. So every single one of these data points is referenced to a geolocation, and you can click on the map to pull those up if you tie everything together correctly. The simple graphs, like on the right, are very easy to create, and they offer increased accessibility due to allowing actions to be put in. So, for example, if you click on any one of those little the bar graphs, it will automatically change that picture of what the fish you are looking at is. This is particularly helpful for the macroinvertebrate things that we do, because I personally don't know my macros, so it's very helpful for me. So one can aggregate the plots in a variety of different and complicated ways. The only way to do that in something like Excel is with pivot tables, but I like Tableau for it, and Tableau does it better and faster, in my opinion. So what are some more intermediate things you can do in Tableau? First, you can make dashboards that complement reports, or replace reports entirely. So the 2022 Action Effectiveness Monitoring Report that we did this year was in a hybrid format, and half of it was in Tableau, and the other half was in a Microsoft Word in a classic format. Each of these datasets can be as public or as private as you want it to be. For example, we recently did something internally with an emerald ash borer potential impacts. That you can only access if we give you a direct link to that thing. Beyond that, you cannot find it. At least I hope you cannot. Tableau adds a lot of sharing of data, so it's really easy. We can just send somebody one of these and they can download all the data themselves and like click of a button, basically. Lastly, Tableau Public really has it has a thriving ecosystem of visionaries. So that means a lot of people use Tableau Public and publish their dashboards to it. There's some very gifted people with Tableau on that. So you can get so much inspiration and just kind of copy other people's formats and make your data look phenomenal. So some more advanced things you can do in Tableau include full coding integration with R and Python. You can also do custom mapping using Mapbox and ArcGIS. So pretty much the sky is the limit. You can do whatever you want because you can code. So this particular example is a model vegetation community and accessibility of Wisp. We have modeled inside ArcGIS the different vegetation communities based upon the UA, the near infrared light that's released. Then in Tableau, we modeled the inundation based on the DEM of the site. Once you get good at Tableau, it's really just art. You know, it's magic and art, really, it seems. So here's an example of the action effectiveness monitoring report that we did. You can see there's buttons to every single section, and you can navigate directly to that. The executive summary, methods, and background are in the traditional separate document that is linked within the Tableau dashboard. Standalone dashboard has the results and the discussion and kind of a site-specific executive summary. There's a link within the report, like the written report, to the Tableau dashboard as well. Here's another example. This is trends in sea level rise based on sediment accretion. So as I mouse over each one, you can see the corresponding site meta or the corresponding plot, like the data point on the plot for the meta. The sea level rise is based upon the Army Corps of Engineers 2020 adaptive hydraulics model scenario. So it has 3 different scenarios of different levels of sea level rise that are forecasted. And they modeled it up and down the river, so you can directly compare that with sea level rise. There's some applications upon that hopefully soon. And here's another complicated example of something that looks deceptively simple. This is comparing the dominance of each canary grass to inundation percent. So we plotted them together, and you can pretty clearly see a relationship between dominance of each canary grass becoming dominant when there is 30% or less inundation at that elevation. So comparing these two data sets directly together is rather challenging inside any other software, so Tableau makes it quite easy to do. Some of our next steps include transitioning all of our data sets into Tableau. We want to focus on creating a quick and useful database for every single metric. After that, we'll be doing a full synthesis analysis of AMER and the ambient metrics. We're going to compare and analyze all the metrics at the estuary-wide scale, beach-specific scale, and the site-specific scale. We want to find the main drivers, if you will, of fish habitat. Next will be the drone inclusion. So we want to include the drone data. We want orthomosaic base maps for every single site, and we want full site-wide statistics and analysis based on the drone data. So we want the modeled vegetation communities and the digital terrain model and some other odds and ends here and there. After that, we'll be doing another full synthesis analysis of all the sites and all the metrics, but this time we'll be focusing on the drivers and the impacts of each metric and develop predictive modeling to further inform the estuary. If you want to look at examples online, here are a bunch for you. We have the action effectiveness monitoring report page with examples. We have the Tableau public page, also with examples, and our science and work group page, or science and work group presentation by this things. The presentation includes a lot of the background behind why we chose Tableau that I did not cover today, but it's worth watching if you are interested. And yeah, please contact us if you have any issues or questions, or just want to chat. Our emails are there. We would like to thank every single researcher who has ever helped us collect data. So thank you. This would not be possible without you. Thanks and have a great day.